in the previous lecture we have studied about cylindrical coordinate system. Today we will see the differential elements in cylindrical coordinate system. Please somebody mute your mic. Somebody has turned your mic on. Please mute. Okay. We will be studying today the differential elements in cylindrical coordinate system, and we will see the conversion from Cartesian to Cartesian coordinate system to cylindrical and vice versa, and few numericals we will solve. Okay. Yes, before proceeding with the differential elements in Cartesian coordinate system, already we have seen the differential elements in rectangular coordinate system, right? So briefly I will tell about that, how it is formed, and then later on I will switch to differential elements in cylindrical coordinate system. Yes, we will recall the rectangular coordinate system, small cube and big cube, point P and P dash. P is having coordinates x, y, z, and P dash x plus dx, y plus dy, and z plus dz, right? So just I will draw and show you people how the differential element had come. I'll draw the small cube first. Okay, let me assume point P is located here. Next I'll draw the big cube. I will not draw the back faces, just it's understood. Okay. If I action, these are my three axes, x axis, y axis, and z axis. X, y, and z. And origin is located here. And point P is having coordinates x, y, and z. And I locate one more point far away from the origin and far away from point P, little bit far away from point P, that is x plus dx, comma y plus dy, comma z plus dz, right? Okay, between point P and P dash there is a volume that exists. Just I will show the volume. What is that volume? See here, this is the volume, right? So this volume, small volume is formed between point P and P dash, this volume, right? This volume, just I will show the okay, between point P and P dash this volume is formed, and the distance from point P to P dash we have called it as differential length dl, right? We already seen differential length dl, and the surface 6 faces have been formed, differential surface area along x direction, y direction, z direction, that we have seen, and differential volume. And the differential elements are dx, dy, dz, the three sides of the volume that is formed here, right? That we have seen, small cube and big cube. Between these point P and P dash there is a small differential element. P and P dash are separated by a very small distance, that is x means x plus dx, in the small distance dx, right? Like that. Hence we call it as differential elements. Okay, we have already seen this in rectangular coordinate system. Now we will move to the cylindrical coordinate system. Yes, in cylindrical coordinate system, let me take I have a small cylinder having some radius rho, small cylinder. Then I will consider one more big cylinder enclosing that small cylinder. Okay, I can take coordinate axis here just like this, x axis, y axis, and z axis. Is it fine? Okay, and I have origin here. Let me assume point P is located. The coordinates of point P I will write here, rho comma phi comma z, because I am considering the cylindrical coordinate system. Let me consider one more point which is far away from point P, little bit far away from point P. Let me call it as P dash, and whose coordinates are rho plus d rho, phi plus d phi, z plus dz. Right, point P and P dash are separated by a very small distance. And the volume that is formed in between point P and P dash, we will try to picture as it here. This is the volume that is formed. Just I am drawing it roughly, but it is not a square. You can imagine, take the cylinder, small cylinder and big cylinder, and imagine the volume that is formed, right? So I'll try to picturize that volume here, how it is formed. This thing, this one I am trying to picture in the second diagram. This is the first diagram. I'll show in the second diagram. Observe here, that small volume that exists between point P and P dash, that I am drawing here in diagram 2. Observe how I am drawing. Okay, point P, the smaller cylinder, this back face or surface is containing point P, sorry, not P dash, P, whose coordinates are rho phi z. And let me take another point P dash on the front face anywhere here at the diagonal, P dash, whose coordinates are rho plus d rho, phi plus d phi, z plus d z, right, on the front face, bigger cylinder. This is the surface of the bigger cylinder. Back is surface of the smaller cylinder, whose radius is rho, and surface of the bigger cylinder, whose radius is rho plus d rho, right? So this is the small differential volume that exists between point P and P dash that I have shown here. So let me take the help of this coordinate axis x, y, z. So for my reference, I am drawing once again. X, y, z. Okay. Just observe here whatever I am drawing. Just I am taking these two lines. I will come to understand I am taking. Okay, just I'll take the projection of this front face on xy plane. Projection of the front face of the bigger cylinder, so that it is intersecting the two lines whatever I have taken here. Then back face, similarly you take the back face. Okay, other one I will not take. So it is intersecting here, front face, one point here it is intersecting, and this is front face. Then if I extend it, this is here, from here origin to this whatever I have drawn, this is a radius. So if I go 360 degree, it will form radius of a bigger cylinder, that is front face. So similarly the cylinder, this one, right, and back face it will come here. So this is the radius of smaller cylinder. If I extend in this direction, it will form smaller cylinder. If I extend in this bigger cylinder, right, whose radius is rho, and for this it is radius is rho plus d rho, right. I hope you understood this. Okay, next we will try to identify the differential elements. See here, P is here in the back face, P dash is here. So I want, this is along radial direction, right, rho. So this is d rho, because rho is the radius of smaller cylinder, rho plus d rho is the radius of bigger cylinder. Rho plus d rho minus rho means I am getting rho. This is the distance rho. Okay, and this face, observe here, this face, what I am making a movement here, this face, if it rotates by 360 degree, it will form a cylinder, right. So this angle is d phi, but I have to take angular distance. The distance, this one is rho, right, from origin to this front face it is rho. So rho d phi, rho into d phi is the angular distance. Just I will not say d phi, rho into d phi. I have to associate the length, radius of that cylinder. So rho into d phi, this side. Then this height, it is along z direction, so it is dz, because z plus dz minus dz minus z, so it will give me dz, right. So these are the three differential elements. So the differential elements in a cylindrical coordinate system is, just I will list out here, d rho, rho into d phi, comma dz. Just simply remember like this, the differential elements are d rho, d phi, dz, but for d phi you have to multiply rho, because it's an angular distance, right. So these are the three differential elements in cylindrical coordinate system. Then I want to find out what is differential length, what is differential surface area, and differential volume, right? Okay, once again totally it has 6 faces, we'll see, right? So differential surface area along rho direction, phi direction, z direction we have to find out. Then differential length means between point P to P dash, join P to P dash. So this will give me the differential length. How to do it, I'll tell you. I'll write first differential length. I will write differential length vector. So the differential elements already we have here. I have written it here, d rho, rho into d phi, just I am rounding it, dz. So make use of that and associate direction and write down the differential length, d rho into a rho. Second differential element is rho into d phi, and unit vector is a phi, plus the third differential element is dz, and the unit vector is az. So this is the differential length. If you want magnitude, so magnitude of dl vector, the distance between point P and P dash, under root of d rho square plus rho d phi whole square, rho d phi whole square plus dz square. So this is about differential length. Then before going for differential surface area, first I will calculate differential volume dV. So we know that the three sides we know, d rho, rho into d phi, dz. So just multiply length into breadth into height, so that will give you volume. So d rho into d phi into dz. First I will write rho, then I will multiply d rho d phi dz, d rho d phi dz. Don't associate any direction for volume, it is a scalar quantity. So just multiply all the three sides, this one here, right? So just I am putting tick mark. So but I am writing rho first, that's all. Rho d phi dz, this is the differential volume. Then coming to the differential surface area, we know this is a formula that is given. Differential surface area ds is equal to the differential surface area multiplied by the unit normal vector an. So but I want differential area along rho direction, differential surface area along rho direction, we'll find out. Then differential surface area along phi direction, then I will write third one here, differential surface area along z direction, because along rho, along phi, along z there exist surfaces. Along rho means just observe which are the surfaces, I will show you in the diagram. Along rho, this surface along rho direction, this is one surface and this is one surface along rho direction. Then along phi means this one along phi, and back one, this is along phi. Z means this one along z, top surface and bottom surface, this is along z, right? Rho phi z. So differential surface area along rho direction I want. Rho direction means back face and front face, right? Let me take the front face along radial direction, means this one, right? This one along front. So which are the two sides of that front face? dz, and one is one side, another side is rho into d phi. Just multiply the two sides, you will get differential surface area. So rho d phi dz, rho d phi dz into, I associate the unit vector. So along this is a rho is the unit vector. So this is simple. Just by geometry we have written. Blindly also we can write. Observe here, I will write the differential elements once again here for the reference. D rho, rho into d phi, dz. These are the three differential elements, right? So I want differential surface area along rho direction means leave this, multiply other two, rho d phi dz, and associate the direction, that's all. Next I want to write differential surface area along phi direction. Instead of looking at the geometry, just what I will do, I will skip this along phi direction and I will multiply other two, means d rho into dz, d rho into dz into a phi. Then I want differential surface area along z direction. Observe here I am putting three dashes here. Yes, I will leave that dz and now I will multiply other two sides, this one, other two sides. So rho into d rho d phi. First I will write rho into d rho d phi into az. So this is the differential surface area along rho direction, phi direction and z direction. Okay. So we have seen the differential elements in cylindrical coordinate system, differential length, differential surface area along rho direction, phi direction, z direction. and the differential volume you have seen, right? If any doubts are there, you can unmute yourself and you can ask once again, either so that I can tell you if you have not understood anything, or else I will move to the next topic. Okay, next part. Already we have seen the differential elements. Next we'll see conversion. Means already we have studied cylindrical coordinate system and rectangular coordinate system. Next I should be in a position to convert from rectangular coordinate system to cylindrical, and cylindrical coordinate system to rectangular. Rectangular is also called as Cartesian, right? Okay, we'll see the conversion, how it is. Suppose I have the vector in Cartesian system. Let me call it as A Cartesian. For my reference, I will write as A Cart. A Cart means A Cartesian. Or else you can write rectangular, RECT also. That notation, you can use anything. A Cartesian is equal to the general vector in Cartesian system is AX into AX, you know it, plus AY into AY plus AZ into AZ. This is the general vector in rectangular coordinate system or Cartesian coordinate system. Next, I will write the general vector in cylindrical coordinate system. For this I will use the notation ACYL. ACYL means A cylindrical. Cartesian cylindrical vector. So I will write the general vector here, arrow into arrow plus A5 into A5 plus AZ into AZ. Okay, this is the general vector in Cartesian system, and this is the general vector in cylindrical system. Next I want to convert Cartesian to cylindrical. Yes, if I want to convert Cartesian, already I have this Cartesian, the vector in Cartesian system. Next I want to find out the vector in cylindrical system. For that I want to find out what is this arrow, what is this A5, so what is this AZ. So for this we will take the help of the projection. Means I want to calculate arrow first, because if I substitute arrow A5 AZ, right, it will be converted to Cartesian. That we'll see. I want arrow first, how it is to be calculated. Arrow is equal to the Cartesian vector, right? I will take the projection of this Cartesian vector in the row direction. So A Cartesian vector into arrow. Means this is nothing but the scalar projection, right? Means I am taking the projection of this Cartesian vector along row direction, so that I will get arrow. If I want A5, take the projection of this Cartesian vector along phi direction. If I want AZ, take the projection of this Cartesian vector along AZ direction. But here AZ no need to calculate, because both are one and the same here. Z coordinate remains the same, because in rectangular system x, y, z. In cylindrical it is rho phi z. The third coordinate remains the same, right? So no need to change. Whatever it is there in both the system, it is same. So next I want to calculate A5. Then the Cartesian vector, the projection of this Cartesian vector in A5 direction. So this is the way to calculate. Then if I want AZ, no need to calculate. AZ is AZ only in both the system, no need to calculate. So substitute this value of arrow A5 AZ in the equation 2, so that it will be converted to cylindrical. Once we solve the problem, we will come to know there how to the cylindrical Cartesian vector, right? This is the general form I am telling. Similarly, this is from Cartesian to cylindrical is over. Cartesian to cylindrical. Next we will see cylindrical to Cartesian, right? So now I have the vector, this cylindrical vector I have. Now I want Cartesian, means I want to calculate AX, AY, AZ. So next cylindrical to Cartesian, let us see cylindrical to Cartesian. Already I have the cylindrical vector. Now I want Cartesian vector, means I want to calculate AX, AY, AZ. So how to calculate? The same way. Take the projection of the cylindrical vector in AX direction, means A cylindrical into AX. So this will give me AX. Similarly AY, take the projection of the cylindrical vector along AY direction. Then AZ is same in both the cases, no need to calculate. AZ is AZ only. So right, so Cartesian to cylindrical and cylindrical to Cartesian, general form we have seen. We will solve few numericals so that you will understand that. Yes, we will take a few numericals. Give the Cartesian coordinates of the point rho, point C is given, rho phi z. rho is 4.4, phi is minus 115 degree, and z is 2. So instead of giving rho phi z, simply I can write c of 4.4 comma minus 115 degree comma 2, right? No need to tell this is rho, this is phi. It is understood because this is rho. If it is middle one is a degree, means this is rho phi z. By default we will understand. No need to tell that rho equal to 4.4. Here they have specified, but no need to specify here, right? So first part A we will solve, one by one we will solve. Give the Cartesian coordinates of point C, that is 4.4 minus 115, and rho phi z is given. They have asked to calculate Cartesian coordinates, part A. Cartesian coordinates means find out x, y, z. X, y, z. C of x, y, z we want to find out. So we know the formula. X is equal to rho cos phi. X equal to rho cos phi. Just the value of rho is 4.4 and cos of phi they are given minus 115. Calculate it. I will also calculate here. I have the calculator. So you also parallelly calculate 4.4 into cos of minus 115 degree. Minus 115. So it turns out to be minus 1.859. So minus 1.859 I am getting 859 degrees. Sorry, 859. That's all. This is x. Similarly, you calculate y. Y equal to rho sin phi. So rho is 4.4 sine of minus 115 degree. You calculate. So I will also calculate here the same thing. Instead of cos, it should be sine. 4.4 into sine of minus 115. So it is minus 3.98 minus 3.98 I am getting. This is y. Then z, no need to calculate. Z is same. Z is 2 means here also z is 2 only. Yes, it is same. So just write down the coordinates of C are x is minus 1.859 and y is minus 3.98 and z is 2. Just verify your answer here. It is there. Yes, this one, right? You have found out the Cartesian coordinates given cylindrical coordinates. Then we'll move to the part B. Yes, part B. Give the cylindrical coordinates of point D they have asked. Point D they have given. Point D is given. So minus 3.1, 2.6, minus 3. This is Cartesian they have given. They have asked to find out cylindrical. Find out D of rho phi z. We want to find out what is D of rho phi z. We'll see. We know the formula once again. Rho is equal to under root of x square plus y square. So this is x, this is y, and this is z. You calculate rho. Similarly, you calculate phi. Phi is equal to tan inverse of y by x. You calculate phi. So tan inverse of what is y? Y is 2.6 and x is 3.1 minus 3.1. So you calculate phi. And z, no need to calculate. Z is minus 3 in both the cases. Z is minus 3. So first calculate rho. So I am calculating rho. Under root of x square plus y square. So under root of x square means here minus 1.859. 1.859 square plus y square 2.6 square. 2.6 square. So 3.19 I am getting. But here they have given the answer as 4.05. Maybe it may be wrong.
Sir, x is equal to minus 3.1 also.
Yes, sorry, I have taken 1.85. No, x is yes, minus 3.1. Yes, I was seeing earlier point, previous point. Sorry. Yes, you have corrected me. Yes, 3.1 square. I have taken 1.859. 3.1 square. Yes, 1 minute I will calculate here. 3.1. 3.1 square plus 2.6 square. Yes, I am getting 4.045. Yes, correct it is 4.045. Similarly, calculate phi. Tan inverse of I am calculating here minus 2.6 divided by 3.1. So minus 39.98 degrees. 1 minute. Yes, I will write it first. Minus whatever I am getting 39.98 degree. One more thing, you have to be very careful while calculating phi, I have told, because just observe the values of x and y and tell in which quadrant it lies. X is minus 3.1 and y is 2.6, means it is coming in second quadrant, right? If it comes in second quadrant, so what I should do, whatever the value of phi I got plus 180 degree if it comes in second quadrant, right? I have to add 180 to it, right? This we have seen. While calculation of phi, we should be very careful. So since the point is coming in second quadrant, because x is minus 3.1 and y is 2.6, so I have to add 180. So I am getting minus 39.98 degree. Add 180 to it so that it will be corrected. 180 degree. In second quadrant means the angle should lie between 90 to 180. 90 to 180. So 180 minus 39.98. So it is 140.02. 140.02 degree. Yes, Z. It is over. So d of rho comma phi comma z you write down. Rho is how much? 4.04 comma phi is 140.02 degree comma z is minus 3. Yes, this is D. Just verify the textbook answer here. Yes, we got it. Then finally the part C, specify the distance from C to D. Yes, it is easy to find out the distance if I know the coordinates of C and D in both in Cartesian system. So already I have C in Cartesian system. It is given. We have calculated in part A. The coordinates of C are minus 1.859, minus 3.98, comma 2. This is in Cartesian system. Minus 1.859 minus 3. And D, the coordinates of D in Cartesian system, it is given minus 3.1, 2.6, minus 3. Yes, now I want to find out distance between C to D, right? So I can find out vector RCD first, then take the magnitude, that is one way, or else directly distance formula, but anyhow we have to make use of vectors. So first find out vector RCD, right? So RCD means minus 3.1, minus of minus it will become plus 1.859. So it is minus 1.241, minus 1.241 AX. First I am writing the vector from C to D. Then 2.6 minus of minus it will become plus 3.98 y coordinate 3.98. So it is 6.58 plus 6.58 AY. Then last one minus 3 minus 2. So it is minus 5 AZ. Then find out the magnitude, that will give the distance between magnitude of RCD. Find out this distance, that is the distance between C to D. Yes, under root of 1.241 square, 1.241 square plus 6.58 square plus 5 square, that is 25. So it turns out to be 8.356. 8.356. Yes, this is the distance. Just verify, it is 8.36 they have given, right? Okay, I hope you understood this problem. Next we'll move to the next numerical. Yes, transform the vector. The vector is given, this is vector in Cartesian system, into cylindrical coordinates. How to convert the given vector, Cartesian vector, into cylindrical, we'll see. First I will write down the given vector f vector. This is given in Cartesian, so I will append Cartesian for my reference. F Cartesian, I will read it as F Cartesian 10ax minus 8ay plus 6az. right? And it is asked to find out, convert it into cylindrical coordinates. So f cylindrical I want, so f cylindrical. So general vector of cylindrical I will write f rho into a rho plus f phi into a phi f z into a z. So this I want in cylindrical. So first find out f rho, f phi and f z. So first I will find out f rho. In order to find out f rho, we have to take the projection of Cartesian vector along rho direction. So the projection of Cartesian vector f Cartesian along the radial direction, that is a rho. Alright, we'll find out this. So f Cartesian I have, I will write it 10ax minus 8ay plus 6az, right? Okay, this into a rho. For this we require a table, because we want ax dot a rho, means we are taking unit vectors, we are taking the multiplication of unit vectors from Cartesian to cylindrical. So we will make that table. So we will write it separately by the sides, it will help us. So ax vector, ay, az. This table, how to form it, I have told in the previous lecture. A rho, a phi, az. X equal to rho cos phi, y is equal to rho sin phi. Az and a rho are they are mutually perpendicular to each other, so it will be 0 if I take the dot product. Then take the derivative of the first column elements with respect to phi. Derivative of cos phi is minus sin phi. How to fill up the table I am already told in the previous class. Derivative of sin phi is cos phi, and the dot product az and a phi, they are mutually perpendicular. Once again it is 0. Then ax dot az, so it is 0 because they are mutually perpendicular to each other. Ay dot, once again they are mutually perpendicular to az dot az, they are similar vectors, so it will be 1. So this table I am ready, right? Next, if I want to take the dot product, now I am ready here. 10 ax dot a rho, ax dot a rho is cos phi, so I will get 10 cos phi. Ax dot a rho means cos phi, 10 cos phi. Next, minus 8 ay dot a rho, ay dot a rho is sin phi, so minus 8 ay dot a rho is sin phi, so write down sin phi. Next, az dot a rho, you check it, az dot a rho is 0, so third term will be 0, so I am getting this is f rho. Yes, this is fine. Okay, they have given one more thing, one more condition they have given. Find out the cylindrical coordinates at this point P. Yes, this point P, 10 minus 8, 6. Then they are given the point P. I will make use of that point P, or else if that point is not given, f rho this much, I will stop here only, because f rho and I will substitute there. So I will go for calculation of f phi. But they have given the point P, so I will make use of that point P. That is 10 minus 8, 6 they have given. This is x, y, z. So I can calculate the value of phi now, because I know x, y, z. So phi is equal to tan inverse of y by x. So just check the values of y and x and y, whether they are lying in which quadrant. Y is minus 8, y is minus 8, yes, negative. Then x is 10, yes, x is 10 and y is minus 9. It is coming in fourth quadrant, no problem, no need to add anything or subtract something. So in fourth quadrant, no problem. Tan inverse of minus 8 divided by 10. So I will calculate here. You also calculate tan inverse of minus 8 divided by 10. So it turns out to be minus 38.65. Yes, it is correct. It is coming in fourth quadrant, right? The angle is also correct, whatever we have calculated. Minus 38.65 degree. Yes. Phi. Just substitute the value of phi in f rho. So I will write f rho after substituting. F rho is equal to 10 cos phi minus 8 sin phi. Substitute the value of phi. 10 cos phi is minus 38.65 into, sorry, not into, minus 8 phi is minus 38.65. I am calculating, so it turns out to be 12.80. 12.80. This is f rho, what we are getting. If that point P is not given, leave it here only. If point P is given, you substitute and calculate, right? Here in this problem, point P is given at this point, right? F rho. Yes, F rho is ready. Next, calculate F phi. We'll go for calculation of F phi. So take the projection of the Cartesian vector along phi direction. F Cartesian into A phi. So F Cartesian I have, that is 10ax minus 8ay plus 6az, and multiply with the A phi. So already I have the table here. We can make use of this table and calculate. Ax dot A phi. Ax dot A phi is minus sin phi. So minus 10 sin phi. Next, minus 8 is there. Ay dot A phi. Just check Ay dot A phi is from this table cos phi. So minus 8 cos phi I will get. Next, plus 6 is there. Az dot A phi. Check the table. Az dot A phi is 0. Right? So I will not write. At point P, once again calculate the value of phi. Already we have calculated value of phi in the previous step, because the same point, right? So substitute the value of phi here and calculate f phi. Just I'll take the calculator and I'll substitute. Minus 10 sin phi. Phi is how much? Minus 38.65. Close the bracket. Minus 8 cos phi. Minus 8 cos phi is minus 38.65. Close this. So and calculate. Finally you will get almost minus 2.9 into 10 power minus 3 means it is almost 0. It is almost 0. I can write it as 0 f phi, because minus 2.9 means engineering. If I calculate, just minus 0.0002. Yes, so I will almost a negligible value. So f phi is 0. I will write. If you want to write down that negligible value, whatever you get in the after calculation, you can write it, no problem. Right? It's almost negligible, 0.0002. Next, fz no need to calculate. Fz is 6 in both the cases. So substitute the value of f rho, f phi, fz in this equation. Right? Call this as equation 1, Cartesian. Call this as 2. Substitute the value of f rho, f phi, fz in equation 2. So finally the cylindrical vector f cylindrical is equal to f rho is how much? 12.8. 12.8 a rho vector. F phi we can neglect it, or else you can write down that value, whatever the small value you got you can write, or else it is 0. Almost I assumed it to be, means it is equal to 0, almost, right? 0 value. So fz is 6 az, right? So this is the answer. Just verify the textbook answer here. 12.81 a rho plus 6 az. Yes, 12.8 a rho plus 6 az. Right? Just check the time. It's already 9:40. Okay, I'll take one more problem, one more numerical. Yes, give the Cartesian coordinates of the vector h vector. Means observe here, in some textbook what they will do, h vector they have given here. I will write down that h vector once again for you people. See here, 20 AR they have written, but actually a rho phi z. Some people, instead of writing rho phi z in some textbook, what they will do, rho phi z, another notation I am telling through this problem, r phi z also some people will write. So if r phi z means, it's understood, r means it is actually rho only. So if r is given, you convert it into rho and write for your convenience. So I will convert and write 20 a rho. They have given AR, but I will make it a rho minus 10 a phi plus 3 az. Right? This is given. This is given in which system? Cartesian. Sorry, cylindrical. H cylindrical. They have asked to calculate the Cartesian coordinates, means H Cartesian. You calculate H Cartesian. Calculate H Cartesian. H Cartesian general vector I will write hx into ax plus hy into ay plus hz into az. So call this as equation 1, first one, and this one you call it as equation 2. they have asked to find out Cartesian coordinates, right? So the same way how we have done previous problem, this is there we have done Cartesian to cylindrical. Here, sorry, yes, Cartesian to cylindrical. Here we have to do cylindrical to Cartesian. That's all. So first I want to calculate hx, hy, hz. So first we'll calculate hx. For this, take the projection of cylindrical vector in x direction. Take the projection of cylindrical vector h cylindrical in x direction. H cylindrical I'll write down whatever they have given. 20 a rho minus 10 fi plus 3 az into ax. Yes, once again I require this table, previous table. Just shall I refer or shall I write it once again? Let me write it once again, because I'll not go back to previous slide once again. Ax, ay, az. A rho, a phi, az, x equal to rho cos phi, y equal to rho sin phi. This will be 0. The derivative of cos phi is minus sin phi. Derivative of sin phi is cos phi, and this is once again 0. Then 0, 0, 1. Yes, this table I am having. So first calculate 20 a rho 20 is there. A rho into ax. A rho into ax is cos phi. 20 cos phi. 20 cos phi. Minus 10 is there. Minus 10. A phi into ax. A phi into ax is minus sin phi. Minus into minus, it will become plus. 10 sin phi, it will become 10 sin phi. Az into ax. Az into ax, you check it. It is 0. So third one no need to write. Yes, we have calculated hx. But they have given the point P here. At point P of so and so. So I will make use of this point P. P is, that is 5, comma 2, comma minus 1. This is x, y, z, right? X, y, z. So calculate phi. Phi equal to tan inverse of y by x. Tan inverse of y by x. So y is 2, x is 5. So which is coming in first quadrant, no problem. So angle should be between 0 to 90 degree, first quadrant, right? Both are positive. So calculate tan inverse of 2 by 5. So I'll take the calculator and I'll calculate. If you also calculate tan inverse of 2 divided by 5. So it turns out to be 21.8. Yes, 21.8 degree. 21.8 degree. So substitute this value of phi in hx. So 20 cos phi. 20 cos phi is 21.8 degrees plus 10 sin phi. 10 sin phi is how much? 21.8. So I am getting 22.28. 22.28 hx. Similarly, you calculate hy. Similarly, hy. How to calculate hy? I will write this h cylindrical into ay vector. So write down h cylindrical vector. So I will write here h cylindrical. This is 20 a rho minus 10 a phi plus 3 az into ay. So we'll see a rho into ay. A rho into ay is sin phi, so 20 sin phi will get. Then minus 10 a phi into ay. A phi into ay, look at the table. A phi into ay cos phi. It's cos phi. So 10, sorry, 10 is there. So minus 10 cos phi. Because if right, then plus 3 az into ay. Az into ay, it is 0. Leave it. Substitute the value of phi, that is 21.8 here. So you will get, after calculation, hy you will get minus 1.856. You will get after substituting the value of phi as 21.8 degree. This is hy. Hz no need to calculate, both are same, that is 3. So substitute the value of hx, hy, hz in equation 2, you will get the Cartesian. H Cartesian is equal to, hx is how much? 22.28 ax. And what is hy? Hy is minus 1.856 ay plus hz is 3az. So we have found out Cartesian. This is the answer. Just verify your answer with this, right? Okay, I hope you understood. So I'll stop the class here. I'll stop